let's look at network attacks. There are definitely different types, even types, so to speak. There's different types of malware. Now, malware is basically short for malicious software. It's code specifically designed to damage, disrupt, steal, action on data, hosts, which is your PCs and networks, and things that come in that category end up being viruses, worms, Trojan horses are some of the types. If you look at some of those major categories, viruses is a type of malware that propagates by inserting a copy of itself into itself. So it just kind of replicates itself similar to what a virus does. It spreads from computer to computer and leaves the infection as it travels. Of course, it can range from severity to causing annoying effects to damaging data and software. It could even cause a denial of service conditions to arrive. Almost all viruses are attached to an executable file. So it means that a virus may exist on a system, but it will not be active or able to spread unless a user runs or opens that program or that file. And then once that code is executed, then the virus code is executed as well. So basically one thing you'll do is be prepared not to open files that you don't know who sent them or what their purpose is. Another type is worms. Now, worms are similar to viruses in that they replicate functional copies of themselves and cause some kind of the same damage, but the difference is in how they require the spreading of an infected host. Worms are more standalone software and don't require a host program or human help to propagate. A worm does need to attach to a program to infect a host and enter the computer, though, through the vulnerability. So the worms kind of take advantage of any system features that allow data to travel through the network unabated. And then, of course, the last one is Trojan horses, where it kind of gets its name from Greek history, where a wooden horse tried to infiltrate, the city of Troy, and inside this gift of this wooden horse, and inside were soldiers that in the middle of the night came out and attacked and opened the gate and allowed the attack to take place. So it kind of looks like, hey, you look at the software, it looks legit, and people are usually tricked into downloading or executing on their file, but after it's there, then a number of attacks can take place, from irritating stuff to the users with pop-ups, windows, or changing the desktop, to damaging the host, like deleting files or stealing data, spreading other malware, such as viruses. So Trojan horses are also known to create backdoors when that happens. So, but unlike viruses or worms, Trojan horses do not reproduce by infecting other files. They self-replicate. So they must be spread by user interaction, such as opening a file or email. So that's why you got to be careful to know who's sending you information. Now, another different type of network attack is called a reconnaissance attack. And basically, just as the name says, what does it do? It's in addition to malicious code attacks, there's some that people just want to observe what's going on. So reconnaissance attack says, hey, I'm just going to discover and map out the lay of the land, what services are running, what vulnerabilities, how quickly does it take somebody to respond? Does anybody respond to an attack? There's an access attack, which says, okay, I'm trying to do unauthorized manipulation of data, So I'm trying to test if I can get in, and then of course denial of service, and that's disabling or corrupting network system services, hence not allowing valid users to get into your system. Now, some of the tools that are used can be NS lookup, whois, to gather information, looking for IP addresses, look for names associated with IP addresses. Then you try to ping the application to try to see if the IP address is available. And of course, there are tools out there such as fping and gping that will automatically kind of automate that step. So you need to, know who's trying to get access to you. Now there are several different things, internet queries, where the threat actor is looking for information about the target. Google search, website organization, whois, just gathering information. And then you got ping sweeps. And ping sweeps basically is, I'm just trying to determine which IP addresses are active. So I'm just going to go through the whole network and think which ones are active, which ones may or may not have thing open. And then port scans, it basically says I'm trying to find active IP addresses and ports that are not protected. One of the things, remember when you're setting up a router, you've got to tell the port you've got to open it up, because by default the router says, hey, the default is that port shut down, and a port scan is just going through and say, hey, which ports did somebody accidentally leave open that they shouldn't have? So if I look at different types of attacks to get access to exploit the vulnerabilities, especially in the authentication services, FTP or web services, to get access to accounts and confidential information. One is password attacks. There's a couple of different types of password attacks. One, it's just brute force. I just keep trying every possible combination. Sometimes it's a Trojan horse attack, where I put enough information up and hope somebody will give me enough information about themselves that I can proceed to gather or guess the password. And then, of course, if passwords aren't encrypted and stuff, you can have packet sniffers to check the internet, cable, Wi-Fi, to see if those passwords are not encrypted. See that diagram? That doesn't help me. Sometimes you get what they call a trust exploitation. In a trust attack, the threat actor uses unauthorized privileges to gain access to the system, but you think it's a valid person. So kind of they broke in, they got themselves, they compromised the system, and then as you're sending information, they strip off what information to it and then pass on that information. So that's kind of that man in the middle piece. But this trusted exploitation says, I'm trying to use that unauthorized privileges to get access to it. Port redirection, it basically says, hey, I use a compromised system. Once I get in, now I can use that as a base against other attacks, other targets. So I'll use a secure shell port 22, and connect to a host, and host A thinks, hey, host B is okay, and let use a unsecured port like Telnet to get access. So once I get in, I can then redirect a compromised host and say, hey, let me Telnet to other devices. So maybe I found one way in, but then I use other tools. If we don't shut them down, if you don't turn off Telnet, an unsecured access service that then they get access to more than you want them to. And then that man in the middle is basically a threat actor puts themselves inside a legitimate business, but all it does is it just is bait data. He captures data going across, doesn't delete it or damage it, just strips off the information and passes it on. So you don't think there's anybody there. Maybe a slight delay, but how many of us actually would know if that data was? So just knowing that those types of cases are. And then, of course, there's the denial of service. Now, denial of service is attacks that usually are most publicized and also the hardest to get rid of because the ease of implementation and potentially significant damage to networks. So they definitely, if you've got a security administrator, they're spending a lot of time making sure this. Now, it definitely takes totally many forms, but basically they prevent authorized people from using the service that they wanted to. Now, how do I prevent denial of service? You just got to make sure you keep all your systems up to date. Latest security updates, operating system updates, application updates. Because all it is I'm just trying to interrupt that service. I'm trying to deny a valid user from getting in. Now, an offshoot of that, and probably in some cases I think is more severe, is distributed denial of service, which then says, yeah, it's similar to the denial of service, but it originates from multiple coordinated sources. Maybe I've got a bank of PCs. One case that I heard about where they started using baby monitors because there was no security on those, and they were able to use the Wi-Fi capability of a baby monitor and tap into that and attack. So it's basically trying to deny service, but I'm using multiple devices, multiple coordination, multiple devices, and it's in a coordinated attack to deny service to a particular service, server. So that is the end of denial of service, or at least as far as network attacks. Let's go on to how do I mitigate some of those attacks.